Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at equivalent fractions. So most people would already know 2 over 8 and 1/4 are equivalent. They have the same value. They're both equal to 0.25. They both occupy the same place on the number line. If you ate 2/8 of a pizza, you have eaten exactly the same amount as if you ate 1/4 of the pizza. So what makes these fractions equivalent? How do we know they're equivalent? Well, the quick way is that these two numbers here should multiply to the same as these two numbers here. 2 times 4 is 8, 1 times 8 is 8. That's how we know that they're equivalent. Another way of looking at this is that two fractions are equivalent if you multiply or divide the numerators, the numbers at the top, by the same number by which you multiply or divide the numerators. So here I've divided the numerator by 2 to get from here to here. I've also divided the denominator by 2 to get from here to here. Because I did the same thing to top and bottom, they are equivalent fractions. So for 3 over 5 and 7 over 10, they are clearly not equivalent. So we write that symbol there meaning not equal to. They don't have the same value. In fact, this fraction is a little more than this one. If you ate 7/10 of a pizza, you've eaten more than if you've eaten 3/5 of it. So that's because with the denominators, we've multiplied by 2, but we haven't done that here. I multiplied the bottom by 2, but I didn't multiply the top by 2. That's why they're not equivalent. So here, this symbol equals means equivalent to or has the same value as. So for this fraction here, if I want these two to be equivalent, notice that I have multiplied 15 by 4. That's how I get to 60. So if they're equivalent, I also need to times the top by 4. So the number that goes in the box there is 40. Now to find the number that goes in the box here is a little more challenging. First, what we're going to do is we're going to simplify the fraction. To simplify a fraction means you find an equivalent fraction with a lower numerator and denominator. So 33 and 88 are both divisible by 11. So I can find an equivalent fraction by dividing by 11. Now the reason I chose to divide top and bottom by 11 of all numbers is the highest common factor of 33 and 88. 11 is the highest number that goes into the numerator and also the denominator. So 33 over 88 is equivalent to 33 divide 11 over 88 divide 11. So 33 over 88 and 3/8 are the same number. They are both equal to 0.375. So now it's really easy to find what goes in the box because you can see clearly I've multiplied the top number here by 8. You multiply 3 by 8 to get 24. So in order that the fractions are equivalent, I must do to the bottom what I did to the top. I'm going to multiply the bottom by 8, so it's 8 times 8, which is 64. So you'll often be asked to simplify fractions, and that means find an equivalent fraction whose numerator and denominator are as small as possible. So 16 over 20 can be written in a simpler way. We simply divide its numerator and denominator by their highest common factor. The highest number that goes into 16 as well as 20 is 4. So 16 divided by 4 is 4, 20 divided by 4 is 5. 16 over 20 and 4 over 5 are equivalent. They have the same value, both equal to 0.8. What about for 27 over 63? Well, the highest number that goes into both of those is 9. 27 divided by 9 gives 3, 63 divided by 9 is 7. So this fraction here cannot be simplified because 3 and 7 have no common factors other than 1. But if you divide top and bottom by 1, you don't change the fraction. So not every fraction can be simplified. A fraction can be simplified when the numerator and denominator share a common factor. You divide them by the highest common factor, but if you have something like this and you don't know easily what the highest common factor of these two numbers is, pick any common factor and keep simplifying. So it might not be obvious what is the highest number that goes into 120 as well as 144. So let's just pick any number that goes into them. Well, they're both even, so I could divide top and bottom by 2. So 120 divided 2 is 60, 144 divided 2 is 72. But this fraction is not simplified because these two numbers share a common factor. That's what happens if you don't pick the highest common factor. If you don't divide numerator and denominator by the highest common factor, you will need to simplify again. So 60 and 72, hopefully we can see they're both multiples of 12. So I'm going to divide top and bottom by 12. 60 divided 12 is 5, 72 divided by 12 is 6. So I've simplified this to 5 over 6. I can't simplify any further because these two numbers have no common factor other than 1. All right, let's now look at comparing fractions. So in maths, when we're comparing two numbers, we're really asking which number is larger and which number is smaller. So when you have two fractions with the same denominator, it's really easy to compare them. Whichever one has the larger numerator is the larger number. So clearly 3/5 is more than 2/5. So we use this symbol here. Remember, this is like a crocodile's mouth. Crocodile wants to eat the larger number. This says 3/5 is greater than 2/5. But it's actually a bit more tricky when the two fractions you're comparing have different denominators. So to get around that, we're going to use equivalent fractions. What I want to do is I want to find a fraction equivalent to this and a fraction equivalent to this where they have the same denominator. So what is the denominator I'm going to pick? I'm going to find an equivalent fraction, but what number should I put on the bottom here? Well, I want the smallest possible number that's divisible by 5 and also 9. So in other words, I want the lowest common multiple of 5 and 9. Well, that's 45. I can times 5 by 9 and I will get 45 on the bottom. But if I want these two fractions here to be equivalent, what I do to the bottom, I must do the top. Because I times the denominator by 9, I must times the numerator by 9. So 3 over 5 and 27 over 45 are the exact same number, both equal to 0.6. On the other hand, for 5 over 9, I want its denominator to be 45. Because that's the smallest number, divisible by 9, also divisible by 5. So I want to times the bottom by 5. So to make sure they're equivalent, I must also times the top by 5. So 5 times 5 is 25. So 5 over 9 is equivalent to 25 over 45. So by making these two fractions have the same denominator, which was the lowest common multiple of 5 and 9, I can easily compare them. Clearly this one's larger. They both have the same denominator, but this one has a larger numerator. So again, I use crocodile's mouth, crocodile eating the larger number. 3 over 5 is bigger than 5 over 9. What about these two? 26 over 50 and 8 over 50. Well, it's hard to compare them because they don't have the same denominator. So I'm going to use the same trick I used in the previous question. I want to find equivalent fractions for this one, 26 over 50, and for 8 over 15, and I want these two to have the same denominator. So what is the denominator I'm going to choose? I want the lowest common multiple of 50 and 15. So that's not easy to do. So when you're in a situation like this with no calculator and you have to find the lowest common multiple, start with the larger number and go through its multiples. So is 50 divisible by 15? No, it's not. Is 100 divisible by 15? No, it's not. But what about 150? Well, 150 is divisible by 50 and also 15. I can make the denominator here 150 if I times by 3. So if I times the bottom by 3, I need to times the top by 3. What you do to the bottom, you must do to the top in equivalent fractions. So how am I going to make this have denominator 150? Well, I need to times the bottom by 10 because 15 times 10 is 150. So if I times the bottom by 10, I must times the top by 10. And I get 80 over 150. So now that I've changed these into fractions that have the same denominator, it's easy to compare. We just look for the one with the bigger numerator. Clearly this one's larger. So the crocodile eats the larger number. This is the crocodile's mouth. It's pointing towards the larger number. This says 26 over 50 is less than 8 over 15. So one other type of equivalence we need to know is that between mixed numbers and improper numbers. So if you have a mixed number and you want to convert to an improper fraction, you take the whole number part, you times by the denominator, and you add the numerator. So 3 times 7 is 21, plus 3 is 24, and you always keep the same denominator. For this one here, we'd go 2 times 12 plus 5. 2 times 12 is 24, plus 5 is 29. You always keep the same denominator. These two are called improper fractions because their numerators are greater than their denominators. So if you want to go the other way, so from an improper fraction to a mixed number, just remember that this line here means divide. This really says 37 divided by 5. So 5 goes into 37 7 times. Remainder 2. The remainder goes up here, and we always keep the same denominator. 43 over 9. 9 goes into 43 4 times. Remainder 7 goes up here, and we keep the same denominator. So in each case, as these are equivalent, they both equal the same thing. For example, here, both of them are equal to 7.4, same value, same place on the number line. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.